All right, let's get started. So when AWS opened up its infrastructure to external customers, there was two things that AWS realized. Number one is that they need to gain customers' trust, so they will upload their workloads, they upload their customers' their own data, and they give it out to AWS. So number one is that security pillar is a must-have in terms of public cloud. Number two, that AWS itself can't protect the data, customers' data, or the cloud infrastructure, because if there is any misconfiguration made by the customer, there might be a security incident anyway. So AWS defined an excellent model for this, and this is the shared responsibility model, which means that AWS split up the responsibilities to two parts. One part is on the cloud provider side, like AWS in our case, and we call it responsibility for security of the cloud. And the other part is on the customer side. This is called security in the cloud. So let's check for the first one, security of the cloud. So obviously, AWS owns the physical infrastructure of the data centers. So AWS has to build it in a way that it is secure. It also has to define guardrails, processes to protect these data centers, which can be like a physical level protection, but it can be like audit or governance or protection around changes, protection of the computation, storage, database, or networking resources. And obviously, AWS also has to keep the software that operates these data centers up to date. So AWS made sure that these infrastructure elements are highly secured. And if we don't really believe in AWS, we can also get certificates that came out from other third-party organizations, audits, and these certifications gives us the information about the security level of the AWS infrastructure. So if we go to AWS console, we can download these more than 100 different security and other certificates that AWS has. So we kind of take this AWS security of the cloud part as a given in this video, and we will more focus on the customer side, because this is the part that we can do anything with. So let's talk a little bit about security in the cloud. There are loads of things that we as AWS customers must do to make sure that we secure our cloud infrastructure. Number one, we need to think about encryption. So we need to make sure that we encrypt our data at rest or in transit. We need to make sure that we configure our network properly, and we use the right tools to check the network traffic. We also need to make sure that we regularly patch our servers. We have the latest operating systems with the latest security bug fixes, and then on the top of these, we also need to make sure that we deploy secure applications. We use secure packages or libraries in our applications, and then also once it's deployed, we handle our customers' data in a secure way. So we have the right processes, right governance processes around accessing this data or auditing the data accesses, or just simply making sure that those can access the data that are authorized to do so. So lots of things, a lot of things going on here, and based on this, despite of the fact that AWS took the responsibility of the infrastructure security, we still have lots of things to do, and there are lots of moving parts here, and we can misconfigure a lot of things. So thankfully, AWS helps us with this, to do the heavy lifting with a wide variety of security services and tools that help us protect our workload. So let's dive into these. As I said, AWS gives us lots of tools to identify, to protect, to identify any misconfigured resource, to protect our infrastructure, to detect any suspicious behavior or suspicious activity within our infrastructure. If we detected something, we can investigate and understand what happened, or we can automate remediation actions. So we can quickly respond, and if there was a problem that we need to recover from, there are tools for recovery as well. So let's walk through the most important services. Let's start with AWS Config. So AWS Config helps with auditing and recording the compliance of our AWS resources. What does that mean? So AWS Config collects all the resources that we provisioned within our AWS accounts, or maybe in our AWS organization. I'm going to come back to this organization concept a bit later. And it then gives us a list of these resources that we can then query or understand and check the configuration of these resources. But this itself wouldn't be easy, because imagine that you have 100,000 resources in your huge AWS account or set of accounts. Having a list of these resources is not enough. You kind of need to define what is compliant and what is not compliant. So to do so, you can define, or you can either choose from one of AWS managed config rules, or you can define your own rules using RDK, that's the rule development kit, basically a Lambda, AWS Lambda in the background that can check a resource configuration and decide if that configuration is compliant or not. If it is not compliant, then it can notify you and let you know that that you need to handle the situation. So these rules can be triggered either when configuration changed, or you can walk through the resources at regular time intervals. But what happens if something is non-compliant? Well, you have two options. Number one, you can get a notification like an email, and go to the console and find out what happened and handle the situation yourself manually. Or you can define remediation automations with the remediation feature of AWS Config. This is basically a set of steps that AWS Config will perform if a resource become non-compliant. If the remediation action wasn't successful, you can configure remediation retries until it succeeds. And this is the logic here is really up to you. AWS can't really find out what you would like to do to handle a given situation. Let's imagine that somebody provisioned an EC2 instance that has SSH port open. AWS wouldn't know what to do with that. You can either terminate the instance or remove the security group, or just simply send an email to the one that created it to terminate it. So there are multiple remediation actions that you might define. It's up to you really to do that, but AWS gives you the tool to do it easily. And one extra addition here. So if you're just getting started with AWS Config and you don't really know or not 100% sure what are the things that you should define rules for. You can pick one of the off-shelf solution from AWS that is organized in conformance specs. These specs can be like a PCI DSS conformance spec that you can release or deploy to your AWS accounts, and it will have a best practice collection of AWS Config rules and remediation actions. I definitely recommend checking that out. Next one, AWS Shield. Now, as AWS is a public cloud provider, it operates with a multi-tenant model. So that means that we run our own workload, sometimes like literally on the same hardware as our neighbor, and that means that if somebody attacks me, it might affect my neighbors as well, which is really not something that AWS would like us to experience. So if we register an AWS account, we've got this DDoS protection called AWS Shield standard activated automatically. This is a free service, and it basically again protects us from the DDoS attacks. If it is not enough, or we would like to have an insurance, we can go with AWS Shield Advanced, which costs us $3,000 per month per organization. But with this, we've got a bit more sophisticated protection against attacks, and we've got better support and a quicker response time. And what is extremely useful is that if we face with higher fees because a DDoS attack, AWS will let us decrease the amount of money that we need to pay. So there is a little insurance included to AWS Shield Advanced. Next service is AWS Web Application Firewall. Now, if you have an application and you would like to have an application layer protection in front of your application to avoid SQL injection or cross-site scripting or other application layer vulnerabilities, then you can go to AWS WAF and use this managed web application firewall service, and basically you can attach these web application firewalls in front of your application layer network entry points like application load balancer, API gateway, CloudFront, and as Andrea will explain, verified access. So how it works, basically when you define a web application firewall resource, you can choose from a list of protection rules. You've got a credit that you can spend on these rules, and you can pick the ones that you would like to have. And that's pretty much it. You can have like here rate-based rules, which is pretty handy. Again, this protects you from DDoS attacks. Okay, let's talk about encryption. So if you upload your data to the cloud, you might want to make 100% sure that that data is encrypted and only available for you, and only you can read it. Now, to do so, the easiest way is to use AWS Key Management Service, which is basically a managed key management service that is seamlessly integrated to basically all of the AWS services that deals with data. For example, EBS, S3, Redshift, RDS, SSM, and so on and so forth. So it's a pretty easy to use service. And I definitely recommend using it if you store your data on AWS. Fun fact, that if you are maybe a business that need to comply to certain compliance rules, then you might need to have a hardware security module, and purchasing hardware like this and operating it in your own on-premise data center can be pretty expensive in terms of TCO. So if you need something like that, you can always go to CloudHSM. There is a managed hardware security module in the cloud, but this case, it is not a multi-tenant hardware. It is a dedicated hardware for you, and you can store your encryption keys and access these keys quite easily, and you don't need to operate it, and you don't need to maintain it on your own infrastructure. Next one. Now we move on the detect phase and check the most important services that are related to it. The first one is Amazon Inspector. So if you might run an EC2 instance in your AWS infrastructure, you might want to make sure that there is no vulnerable softwares running on the EC2 instance, or the EC2 instance doesn't do any suspicious network activities. If that is your case, then you can go with Amazon Inspector, and you can install an Amazon Inspector agent to the EC2 instance, and that will do security assessment and flags you anything that is suspicious. It can also notify you if there is some strange things going on. Next one, Amazon Macie. Again, pretty useful service. So if you store lots of data in Amazon S3, and then you might want to know if this data contains personally identifiable information, because then if so, then you might need to handle the data in a different way, different governance rules, different authorization, and so on. Or you know that there shouldn't be any PII in the data, and it's just a check to make sure that there is nothing there, really. Good thing here is that from last year's reInvent, you don't need to ship your CloudWatch logs to an S3 bucket and then run Macie to find out if there were PII information in the logs. But now you can turn on CloudWatch PII checker, and you can get alerted if you started logging something that you shouldn't do. Next one, AWS GuardDuty. AWS GuardDuty is an intelligent threat discovery to protect your AWS workloads. It uses machine learning and predefined pattern matching logic, and it checks your CloudTrail logs, your VPC logs, basically your network traffic logs, or your DNS query logs. And using this information and the machine learning model, it flags if something suspicious happening in your accounts. Again, pretty easy to use service, and it can save you from lots of trouble. Finally, I already talked about lots of security services and tools, and you might want to collect all the information to one place and to have one surface where you can manage these security-related things. And if so, then you should go to AWS Security Hub. That gives you consolidated findings across AWS services and partner integrations. With AWS Security Hub, you can integrate with your own CM system or your ticketing system. Next. CloudTrail. CloudTrail is probably one of the most important security features of AWS. If you register an account in AWS and you would like to understand what's going on in your account, you can go to CloudTrail, because CloudTrail will log all the AWS API calls that you perform within an account, and you can understand who did what within your AWS account. For example, if somebody provisioned an EC2 instance in your account, and you would like to know who did that, you go to CloudTrail, check, search for the EC2 instance creation or provisioning action, and you can find out who invoked the API endpoint that ended up creating EC2 instance for you. So again, a must-have service, and it can save you a lots of time if you know how to use it. What it does is basically it collects events. These events can be can have two types. They can be either management events. These are the things that I mentioned before, like provisioning a new EC2 instance, creating a S3 bucket, removing a security group, creating an IAM user, things like that. Extremely useful information, again. And then you can have data events. Now, these events can be pretty like high volume events, like in terms of amount. So while management event tracking is turned on by default when you register an AWS account, data events are not enabled. So if you need it for compliance or any other reason, you can enable it, but be careful, because again, you might have lots of data events, so it might not be that what you want. And if you want to query these events and you want to search and understand what's going on, you can use CloudTrail Insights. Okay, let's move on and talk a little bit about identity and access management. But before we do so, first things first, let's talk about AWS Organization. I already mentioned this concept, and I promise you that I will explain it a bit more than details. So if you have multiple workloads running in the AWS cloud, or you have multiple environments, maybe you might want to separate these things to different AWS accounts. There are lots of benefits when you do this. So number one, you can be 100% sure that anything that you do in a given account won't affect other workloads. Okay, so you have a dev account, let's say, and a prod account. If you change something in your development account, for the sake of experimenting, for example, you can be 100% sure that it wouldn't affect your production workload. That's one thing. There are quite a few quotas or limitations that are based on accounts. So if you don't want to run out of these quotas, you might want to separate your workloads to different accounts. Also, you can have consolidated pricing and volume discounts. So you can aggregate these accounts under one organization, and you can have volume discounts for a given organization. So that's why organization itself is good. It's not really about separating things to accounts. It's about separating things into account and registering them under one organization. And there are many security aspects of separating workloads to different accounts. You have better governance. You can have better authorization rule sets. You have better visibility over costs, and also the following: service control policy. So with SCPs, you can define IAM policies on account or organization unit level. You can have, as I mentioned before, multiple accounts within an organization, and you can organize these accounts under organization units, and then you can apply service control policies to either organization unit level or on account level. These service control policies are the highest priority policies. Soon we'll see the policy evaluation corner. So if you define an SCP on an account, that will be the strongest one. So you can't do anything. In other words, you can't do anything in an account that an SCP doesn't allow you to do. This is so the SCPs are applied to all users and roles, including the root users. There's one thing that these SCPs not applied, and this is the service link roles. It might be because these are usually the roles that AWS services use, and if we apply them, we might have unexpected behavior. So again, SCPs must have an explicit allow, otherwise you can't do it in the account. Pretty strong tool. Okay, so I kind of touched upon this topic, but let's talk about the actual identity and access management service. And first, let's check the components, and then later on, I'm gonna have a little hands-on section so we can play with these components as well. So first, we have users, groups, and roles, and these are basically the principals that can do things in an AWS account. Okay, users can be within a group or in multiple groups, and we can assume roles with users or other AWS services, and if we did that, then we can act as we would be the given role. And then we have policies. So these are the documents that describes what a given principal can do. We can attach these policies to principals like users, groups, and roles, but we can also attach these policies to resources like an S3 bucket, or we can define permission boundaries, which is basically a guardrail for a principal, and then we can attach these policies to sessions. So these policies are like a pretty generic usage things. On the right-hand side, you can see a policy example. Each and every policy had this structure, but there are elements that are optional. So these are in JSON format. So the policies basically are defined in JSON. We have the statement attribute that is an array with statements. Each statement has a statement ID that needs to be unique. An effect, which can be allow or deny. Obviously, this will define if we can do a certain thing or not. Principal is an optional one. It depends on the context. If we apply it, for example, to a resource, then with this principal attribute, we can tell who is the principal that can use me as a resource. Like if we attach it to an S3 bucket, we can say that IAM role can list objects in this S3 bucket. So we can attach this policy document to the S3 bucket, and that will give access to the IAM role to list objects. The action is what the principal actually can do. These actions are usually prefixed with the service name. In the S3 bucket example, it would be like S3 list object. And then we can define the resource. This is basically the AWS resource that we give or that we allow or deny access to. And then we finally have another optional attribute called condition. This is the funniest bit because the content of the condition attribute might be different in different places where we use these documents. So it's always a slightly challenging bit to find out what to use in condition, but you don't need to use it always. And here is the IAM policy evaluation logic. I'm gonna just quickly walk through it. So if you have an explicit deny, that's the strongest policy element, then the answer for a question is gonna be that no, you can't do that. If your organization's service control policy doesn't enable you to do a given action on a given resource, then again the answer is deny. But if it allows you to do that, you still can't access it unless, for example, there is a resource-based policy. So, for example, you have an S3 bucket, and your S3 bucket gives you permission. Then you can do the certain action. But if you don't have it on that given resource, and you can't attach resource-based policies to each and every AWS resource. There are certain resources that support these, and the most of the resources don't support this. So again, if you don't have this resource-based policy, AWS will check if there is any IAM permission boundary. So if it doesn't let you do it, then again, deny. It will then check your session policies, and finally, it will check if your identity-based policies enable you to do a certain action on a certain resource or not. If there is an allow, then happy days, you are allowed to do a certain action. If there is nothing there, like that means you got an implicit deny. Now you might wonder, like this diagram is not obvious to understand for the first glance, and so you might wonder if there is any tooling around this that can help you to debug or understand what's going on in terms of your IAM policies. So good news is that there are quite a few tools out there. So the first one is the IAM credentials report, which gives you an account level list of your principals and the status of their various credentials. Again, a pretty useful thing. And then if you want to focus on one given principal, like let's say a user or a role, you can use IAM Access Advisor that lists all the permissions that a given principal has, and it will also tell you what are the actions that it actually performed. So you can check if this given principal really needs all the permissions that it has, or you can make it leaner, or you can apply the least privilege principle a bit better. And then finally, if you are performing action with an SDK call with CLI and you got an unauthorized access error, the best place to go is CloudTrail and check CloudTrail logs, because you should see the rejections there, and that can help you out when you want to understand why you couldn't perform a given, let's say, SDK or CLI command. And now, jump on the hands-on part. So, the first exercise here is the following. I'm gonna deploy an IAM role to AWS. And I'm going to also attach a policy to this IAM role. Okay, this policy is going to be a deny all policy, meaning that if we go back to the diagram, we are on the left-hand side. So in theory, we should get an explicit deny. And I'm going to show you guys command that, despite of the fact of this official diagram from AWS, can still perform when you have explicit deny on every actions and resources. So let's see the code. The first one. This is my own IAM user here. This is gonna be the IAM policy document that we release, and I'm gonna attach this to this given role. So I'm gonna export the profile that I will use here. And run a Terraform apply. It would like to create 3 resources. Okay, let's go with that. And let's see, what did we do? Jump on the roles tab, IAM role, and as you can see, we have a new role, and we also have an explicit deny all command attached to it. And now my statement was, there is actually something that we can do despite of the fact that there was an explicit deny, and this command here is a funny exception of the deny all rule. Basically, this is because if you have an unauthorized access, AWS will tell you what your principal is. So running this wouldn't really give you extra information. It is just something that you could get anyway. But yeah, it's a funny example of like deny all rule and still being able to do something. Okay, next exercise. I'm gonna deploy an S3 bucket, and I'm gonna attach resource-based policy to this S3 bucket, which will enable this IAM role to list objects. And we will check if we can actually list these or we need something else to do. Okay, quickly the code is the same. I remove the deny all. I'm going to create an S3 bucket, upload the test object, and here I defined the IAM policy. I give access to this role to do a list bucket action on the given bucket. Okay, it's deployed, and just quickly check it. So here we can see that this role can't do anything by itself. So we need something to be able to list those objects. Let's see the S3 bucket here, permissions, and we can see that in the S3 bucket resource-based policies, we can indeed see an allow statement to list the bucket and this given bucket, and it gives access to this meetup for IAM role. So now let's run CLI command and try to list the bucket. And as expected, can do that. Next exercise. Okay, let's create now private VPC. So private meaning that anything that is within the VPC can't access the internet, and anything that is outside of the VPC can't access the workloads within the VPC. Okay, so like a separated network that nobody can access, and it can't access anything outside of the network. And to this network, I'm going to deploy an EC2 instance, and we will check if we can actually access an S3 bucket using a thing called instance profile. Basically, an instance profile, it helps you to avoid injecting IAM credentials within your EC2 instance, because within this instance profile, you can act as the IAM role that we define, that anything that happens within the EC2 instance happen in the name of this in the name of this role. Okay, let's see the code. So the same is here. One change here is that I added an extra statement for the assume role policies. Basically, this means that I enable my EC2 instance to use this role, to act in the name of this role. We still have the S3 bucket, still everything. We define our VPC and an EC2 instance. So let's apply it. All right, now that we applied these changes, let's see what happened on the console. So now we see a brand new EC2 instance. If we go to the right region, so here we see this instance running, and we can connect to it. Let's see if there is AWS CLI configured. It is. And now that we are on this EC2 instance, let's try to perform a list action. And what we experience here is that we can't get any answers. And the reason behind this, and I'm going to just stop the execution here, is that we are on a private network, meaning that we can't access anything in the internet. And unfortunately, AWS API is like on the internet in a way. So we need to do something. Now here there are two options. We can either open up this VPC to the internet, which might not be the thing that we really want to do. And we can also define gateway endpoints here within the network. And these are the network resources that can give us direct access to the AWS API. And once we send a request via these gateway endpoints to the AWS API, the request itself won't leave AWS's internal network backbone. So we won't do that. We go out to the internet and come back to AWS and come back to the internet and go back to the EC2 instance, but we remain in the private network of AWS, which is a pretty useful thing to do. and also a really secure and cost-effective way of accessing objects from a private network in S3. So what I'm going to do is I'm going to provision this gateway endpoint and see if this is enough or not. Right? Let's come back to our terminal, and indeed now we can access this S3 bucket. And the final one is when we would like to access an S3 bucket that is not within our account. This is like a cross-account S3 bucket access. And to do so, we need to do two things. So we will create a new bucket. We will attach the exact same policy document to the second bucket. Obviously, the bucket name is going to be different, but we'll give access to the IAM role. And also, to have this cross-account access privilege, we will attach an explicit, in an explicit way, IAM policy to the role that will enable this role to go to that second bucket and list the objects. So the code is the following. Everything is the same that we had before, except that we create another bucket in a different account, and we attach the same policy to this account. So IAM role as an identifier, and the S3 bucket's name as a resource. And then we will attach a list bucket policy to our IAM role. All right, let's see if this works or not. So what I'm going to do is I'm going to go to the second bucket, meetup for dash second dash 1, 2, 3, and try to list the object. And as you can see, we could do that. So now I'm going to pass the mic to Adrian to talk about Zero Trust, Verified Access, and Verified Permissions.
Now let's have a look at Zero Trust in AWS. Zero Trust has been here for about 1.5 decades by now, and cloud providers also thought about it to help the community and help those who are using AWS to let's take a step in the direction of Zero Trust. So what is Zero Trust anyway? Zero Trust is a security framework which basically tells do not have a pre-established trust about a network or a user or a device. Let's do a verification every time a request is made. So basically, we have a service that verifies the requests, and we have our applications accessible through this service. In this case, what we are going to have a look now is AWS's Verified Access that will make this possible. There are a lot of advantages of Zero Trust. Then we have an implemented Zero Trust framework in our system. Since we are using this to access our application, we are going to have every request going through this service. This makes it possible to centrally manage not only the access controls, but also the configurations, the permissions, or the policies where permissions are defined, we can log the requests, we can monitor the traffic that goes through on this service, verification service. We can continuously monitor the usage of our applications, and we can have a quite good visibility what's happening on our network through these services. Since we have a service that verifies these requests, these can replace some of the VPN servers. In those use cases where we can use such a service, there is no need for a VPN server. There is no need for having a VPN client on the user's device. There is no need for the IT operations team, the corporation, to maintain the VPN servers. We can have this service deployed centrally and have a managed service as a VPN server in the background, for example. We can configure these by endpoints. We can have these on an application level configured, so all the applications can be handled separately, and we can configure each verification on an application level. So we have heard a lot about the security in AWS. AWS spent a lot of time and money and invested a lot to have a secure cloud. Probably if you would like to look around and ask the question to yourself, is the cloud secure? Is AWS secure? You will probably find the answer that yes, it is secure. If you would like to have third parties certifying that AWS is secure, then you can have a look at any of those lot of certifications. Currently, there are 143 certifications that prove that AWS is a secure cloud. For example, PCI DSS, HIPAA, GDPR, FIPS, and so on. AWS not only provides these certifications, but if you are on the builder side, if you are a solution architect, and you are implementing these systems, you can have a look at all the resources that AWS provides. AWS has a well-architected framework that you can check out and have a look at. You can read all the white papers that AWS provides, or you can have a detailed understanding of how the services work. You can have a look at the reference architectures and the blueprints from which you can have a quite good insight how you should put together common use cases. These are going to provide you architecture designs for the most general use cases, the most frequently used architecture setups, and you don't need to reinvent the wheel. You can take one of these and modify them to your use case. The blueprints are already ready to use components, so if you find some of them as a solution for your requirement, then you can use them right away. I put here two of these reference architectures on the slide. They are just examples of what you can have there. There are much more complex architectures where you can get insights from. So how comes zero trust in the AWS, and what is verified access? So verified access is going to help you to improve the security posture of your applications and help you to make a step towards zero trust. Each and every request is going to be verified, evaluated and verified by verified access, and you can have your application hosted in a VPC in a private subnet. There is no access from the internet, there is no NAT gateway, there is no internet gateway deployed, it's entirely private. And then you can have verified access, which is going to implement in the background the connection to your private application. It is going to be available through verified access. You can bound these in security groups. So the security groups, you can control all the inbound and outbound connections between verified access and between your applications. So as you would configure it with any other service, it is very similar. It is going to improve the user experience since they don't have to install, update, and manage their clients, VPN clients on their computers. There is no infrastructure maintenance from the IT operations side, so you don't need to scale your VPN servers, you don't need to update them, patch them, and configure them. There is a simpler troubleshooting since every application access goes through this central service, which is going to log all the requests if you configure it so. And here you can also check if something is not allowed. You can have a look at the policies. All your integrated applications are going to have a central common policy set, which is going to be in the same language, the same place, of course, separated for every application, but in a central place where you can manage these. There are a lot of applications in AWS which you can configure and which are integrated with verified access at the moment, but still this is a very new service. This has just been announced last year, the reInvent, so there are a lot more features coming. So how does verified access look like? The components of verified access, the first one is the verified access instance. This is basically the compute power behind verified access. This is going to be the engine which is going to evaluate the request for you. And then you have the endpoints, verified access endpoints, which are going to represent an application of yours. So if you have 5 applications, then you would have 5 verified access endpoints for these. Then you can create verified access groups, which are going to group together applications that have the same or similar security requirements, because you can define policies on an application level, which in this case is an endpoint, and also on a group level, and this makes it possible to avoid a lot of redundant configuration for all of your applications. The next component here is the access policies, the verified access policies, which are going to define the permissions that are allowed regarding an application or a group. There are the trust providers. The trust providers are going to be used by verified access to establish or to get user or device information. Basically, these can be user or device trust providers, for example, Keycloak, that we are going to see in an example later. And the trust data is going to be the details sent by the trust provider. This is going to be used by verified access, and this is going to be verified against the policies. So let's have a look at the architecture a bit more in detail. So we have the verified access. In the verified access, we have all the created resources. And we also have the VPC, which is set up with a private application. And in this case, it is going to be a Lambda function, but it could be a lot more. The direct target of a verified access endpoint can be a load balancer or an ENI, an elastic network interface. And through a load balancer, you can configure an EKS cluster, Lambda functions, for example, Fargate cluster, EC2 instances or auto-scaling groups, and so on. This is how it's going to look like. Then it comes to the trust providers. A trust provider can be a user or a device type. It's something you need to configure at creation. A user type trust provider can either be IAM's identity center or any third-party identity provider that conforms to the OpenID Connect protocol. So if you have something like Keycloak, which is compatible with OIDC, then you can configure it with verified access. And then you can have device-based trust providers, which can currently be CrowdStrike or Jamf. The trust data is then when you authenticate to your application, it goes for verification to the verified access. Then the trust data is going to be also forwarded in a JSON web token to your application. And this comes very handy because if you remember, for example, in a traditional manner, when you have a VPN server and you have a trusted internal network, you usually connect to the VPN. You have the established tunnel that you can use, and then sometimes you need to re-authenticate to your applications. So since you are on the network, you are granted access to some of the applications, but then still you probably need an authentication. Then you would like to act as a user, not simply as a general access to an application on the network. And this is a re-authentication. So if you consider the VPN connection as a first step, then you do an authentication. In this case, there is a so-called user claim testing, which verified access is going to forward the user data to your application in this JSON Web Token. That's how your application is aware of which user is making this request, and there is no need for re-authentication. Then also you can use the verified access groups for grouping together these applications, and you can have your common rule sets defined on the group level and on an endpoint level. And recently, AWS has just announced that you can configure web application firewall on verified access instances, so you can also have layer 7 rules defined in a firewall for your verified access instance. And what is the price of this? Currently, there is a monthly charge for verified access, and it is charged on an application level, basically on an endpoint level, which is the representation of an application in verified access. So there is currently in Frankfurt, it is $226 per month if you have an application. And also there is a per gigabyte charge for data processed, which is if you have a data intensive application, you must also calculate with that. And now there is going to be a short demo how verified access works, how can we configure the components that it has, and what logs can you see in the verified access logs, and what you can log from Lambda, for example. So let's have a brief look at the architecture that is going to be in the demo. So there is going to be a simply configured publicly available key cloak. This is going to be available on an HTTPS endpoint. There it's behind the load balancer, and there is an EC2 instance having a Docker container with key cloak and publicly available. Also, we have key cloak configured in a way that we can test verified access. There are two groups. There is a manager group and there is an engineer group. And in the engineer, there is one user, engineer Emma in this case. And in the manager group, there is manager Mario and not verified Noah. Noah does not have its email verified, so we will have a policy that is going to restrict access based on email verification, and that is what we are going to test with this. And let's have a look at the architecture a bit more in detail, even more detailed architecture. So we are going to have these two policies. One is going to be the email verification check, which I mentioned. It's going to be in the group level. And the other one is going to be on an endpoint level. And this is going to be a group membership check, whether it's a manager or an engineer. So how verified access works, it is connected with the publicly available trust provider that we have seen, Keycloak in this case in the previous slide. And verified access is going to create an ENI within the private subnet, and it's managed by AWS or managed by verified access. And that's how it is going to connect to the private load balancer that we have in front of the application. This VPC does not have any connection to the internet. It's just verified access who creates a connection in the background. And also, all of these security groups are configured in a way that a security group has only an inbound rule which allows the invocation from the verified access security group. And the verified access security group only allows an outbound connection to this ALB security group. And now let's have a look at the policies. So as I mentioned, there are going to be two policies here. One of them that checks the email verification, and the other one that checks the group membership of the user who is performing the request. These policies are defined in a language called Cedar, and these are a language that can be used for defining policies in verified permission that I'm going to talk about a bit later as well. So when you have these policies defined, you can set it on a group level and an endpoint level, but you are not required to set both of these. So any of these can be turned off, and both of them can be turned on. And when you have one of them turned on, then it's going to be evaluated. When you have both of them turned on, then both of the checks are going to be evaluated one by one, and both should allow the request, and that is going to be a request that can reach your application. So now let's have a look at the demo itself. In the demo, I am going to log into Keycloak first, which is available on keycloak.serverlessbudapest.com. And I'm going to show you the configuration here. We have two groups. We have engineer group and the manager group. And in engineer, we have engineer Emma configured. And in the manager group, we have manager Mario and not verified Noah. In Keycloak, groups are not forwarded in an authentication in the trust data to the application. You also need to configure a groups attribute. So that is what we have right here. It's a groups client scope, which is configured to have the group membership as a mapper. And we have a client configured for verified access. And here in the client scopes, we have the groups configured as a default scope. Because this is a default scope, this is by default going to be forwarded to the application. There is nothing that you need to configure with verified access in order to get this attribute. So now let's have a look at a sign out and have a look at the application itself, which is app.serverlessbudapest.com. I'm automatically redirected to Keycloak to perform a login. I first going to log in with manager Mario. As you can see, we can access the application. So manager Mario has access to the application. The application is very simple. It returns the user who makes the request and the email address of the user. So now I'm going to open the application again. And now I'm going to log in with engineer Emma. Engineer Emma is not going to pass the authorization. So we get an unauthorized error. And I'm going to open the app again. And now I'm going to log in with not verified Noah, who is also going to be authorized. All right, so we have seen how the application works. Now let's have a look at those cookies that are forwarded in the request and how this whole authentication works. So when I go to app.serverlessbudapest.com, I'm going to open up the developer console here to have a detailed look at what's happening in the background. Let's do this once more. And we would like to see all the requests. And when we enter to app.serverlessbudapest.com, we are automatically redirected to Keycloak. So we get a 302 redirect, and we are redirected to Keycloak. All right, we perform a login. Let's use manager Mario in this case. I'm going to clear the history here. Now we can see that we have the backend response from the application, and this is already coming from our backend application. You can see the response is very simple, a few information about the user. So now let's have a look at the cookies set by verified access, because that's how the session is maintained. Now I'm going to clear all the cookies here. I go back to the network tab. I also clear history and I perform a refresh. We can see that we are still logged in because we are logged in Keycloak. And when we perform the refresh, there was no verified access cookie, but we were automatically redirected to Keycloak. Keycloak performed the login, and we were redirected back to the application. That's what we can see here in the request history, we can see that we were redirected to Keycloak, and when there was the response from verified access, we can see the application itself. Now I'm going to clear the cookies again, and I will also go to Keycloak and perform a logout from Keycloak. And now I'm going to go to app.serverlessbudapest.com, and now I'm redirected to Keycloak. So when we are logged out from Keycloak and also the verified access application level session cookies cleared, then we will do a re-authentication. And this is very important because it's different to have an application logout, and it's different to have a Keycloak or identity provider logout. So this is something that we should keep in mind. All right, so let's have a look at AWS. What do we have here? We have a backend Lambda application, a very simple application. This was written in TypeScript, and the compiled JavaScript file is also very simple, so we can have a look at it like this. There are a few things logged to the console, as we will see in CloudWatch. And we can also see here that we are using the library and we are decoding the JSON web token. We can see here that this is the header where this token is forwarded by verified access. All right, so we simply log the decoded JWT token, and we are returning a simple HTML response with the name and the email address of the requester. Now let's have a look at the verified access configuration. First, we have the verified access instance. The verified access instance has a verified access group configured, and it has a trust provider, which is Keycloak going to be. It also has CloudWatch access logging configuration enabled, because we are also going to have a look at the requests that are logged by verified access. And also, these integrations here, this makes it possible to configure Web Application Firewall with a verified access instance. Here we have the trust provider configured. It is a user-type trust provider, OIDC trust provider. And we have all the trust provider details configured here, which are basically the required attributes with an OIDC provider. We have the client ID, that is configured in Keycloak, and we also have these two scopes, OpenID and email configured. You must have OpenID here to make this work. And also, if we would not have, when we don't have the default scope configuration in Keycloak that I just shown you, the groups, then you should have here the groups or any other attribute that you would like to get either for verified access for verification or to your application. Now groups is a default scope, so it's automatically forwarded to verified access. Then we have the verified access groups. And for the verified access group created for this demonstration, there is this policy, it is enabled, and there is only one constraint here, the Keycloak email verified true constraint. And here, the Keycloak is the name of the trust provider that we have configured previously. So if we have a look at the trust provider, there is a policy reference name, and the policy reference name is going to be the attribute how you would like to reference to the attributes forwarded by the trust provider. So Keycloak forwards an attribute called email verified, and it's a Boolean variable, so we can check if email verified is true. And we have one endpoint associated with this verified access group. And this is the application representation within verified access. So we have a lot of things configured here. We have the application domain name. This is available on HTTPS. So we also have a domain certificate configured here. We have a certificate in AWS Certificate Manager. And we also have an endpoint here. And there is also a load balancer in the background, so that's how it's connected. Also, we can see the load balancer details here, the subnet configuration, the protocol, the port, and the load balancer itself. We also have a policy here. This is also enabled. And here we have a group membership check. It is going to check if the requester is within the manager user. That's why a Genie-Remma cannot access the application. All right, and now let's have a look at CloudWatch. There are two interesting log groups here. One of them is the Lambda, because in the Lambda logs, we are going to see the request details, for example, the event itself. So there are a lot of information here. There is a request context. We can also see the JSON Web Token, which is forwarded. This is the user's claims passing that we have seen in the previous slides. And we can also see here the IP address of the requester and also the private IP address of the ENI, which was created by Verified Access. We also have the context here. And we also have the decoded JWT token. Here, this is the claims passing, so these are passed by Verified Access. We have the email verified attribute, which is checked, and we also have a few more attributes. Groups is the other one, which is verified. All right, and for the other one, I'm going to go to Logs Inside, because here I would like to show you what can we see in the Verified Access's access logs. So if we search for example, filter the message like Mario, I will increase the interval that we are searching a bit here. So when we have a look at the Verified Access logs, we can see that, for example, the authorization was performed twice because there was an authorization against the group level policy and against another one against the endpoint level policy. So we can see that both of these are allowed. Another very important thing is that we have here the public IP address of Verified Access, and we also have here the public IP address of the requester. All right, let's have another look at, for example, Noah. Noah is the user whose email address is not verified. So if we check Noah, we can see that for Noah, there were two authorizations, and one of them is allowed, and the other one is denied. All right, so the first one was allowed because it's also a manager, and the other one was denied because the email address is not verified. We have Emma as well. Emma is not part of the group, which is verified. And in this case, we can only see one single deny. And this is because in Verified Access, there is a short circuit evaluation logic, which means that if there is a deny, it's not going to perform a check for the other one, for example, for the group or to the policy, to the endpoint policy, because both should be allowed to allow the request to the backend application. All right, so basically that is how Verified Access works. And now let's continue with verified permissions. Verified permissions is, at the moment of this recording, it is not, it's only publicly available in a preview, so it's not generally available. So we still don't have all the details and how it works, but it's already very promising and it's worth talking about. So verified permission is going to make it possible to have your application's fine-grained access control, fine-grained authorization part offloaded from your application. So you probably came across during application development with the task to implement an authorization layer. You can have different roles like an administrator who is using your application. You can have different types of users based on some kind of roles that you would like to have different access for them in your application. And you need to perform an authorization and check if that role is administrator or manager or something else, and they allow only certain actions. This is something that you need to implement in an application, but you can also use verified permissions for it. Verified permission is going to provide you an evaluation engine. It is going to provide you a place to have your policies, and the details of the policies can be defined by you for your application. You can design the schema of these, and also you can have your own actions that your application can do. You can do this using the Cedar language, and this is an example policy here. So for example, you can check a group membership in this case. Verified permissions also contains the schema definitions, and it has also not only the statement grammar, but also an automated reasoning for it. And this makes it much easier to develop applications with fine-grained authorization, and also it makes one more step towards zero trust. And what kind of authorization strategy is possible to be implemented using verified permissions? Well, there is role-based access control and attribute-based access control. Both of these can be expressed using verified permissions. So in the first scenario, you can see, for example, a role-based access control. The simple group membership constraint is what is defined in the policy. In the second example, it is an attribute-based access control. There is an attribute of the resource and the principal which is checked for a certain constraint. Verified permissions makes it possible to not only express these kind of authorization strategies, but also makes it possible to perform or write a condition and a principal, action, resource, and also conditions. If you have used IAM before, you have probably seen this, because in IAM you can also do these constraints, and the expressiveness of this kind of description is very powerful. So it can be very complex, but you can express almost anything regarding these four entities. Since the policy evaluation is not performed by your application, the compute requirement of this can be offloaded from your application, and verified permission is going to do this. You can call an API and you can have a response allow or deny, and then in your application you can simply continue based on the decision. It is performant, it is readable, and you can have this common expression, this common language that defines the permission policies for your different applications. And also, already there are best practices using Cedar. As probably you have seen in IAM, when you define a policy, there we are using ARNs, which are the Amazon resource names. Here, you should also define the unique identifiers of principles that you would like to have constraints on. Because if you don't have the unique identifier but the username, then when the username changes, your policies are going to lose. They are going to not be the same as previously, all right? So when two usernames are changed, and for example, the one changes to the second and the second changes to the first one, then they have the policies acting differently than what you would expect. You can also use groups so that you have less policies to maintain, because you can define these permissions on a group level, which makes it easier to manage them in the long run. And you can also use namespaces, which you should, because let's consider multiple applications, And if you have, for example, two which have the same kind of actions, like list items in this case, then how would you make a difference between them? And that's where namespacing comes very useful, because then you have, for example, app1 action list items, and you can have app2 actions list items, and then you can have the differentiation based on this namespace. The permission guardrails and simplifications can be performed by two very useful keywords. This is forbid and unless, and it makes it readable and easier to express certain conditions. There is also a very fancy feature, which is that you can use templates. So let's say you have a photo gallery application where you have users and they can have photos uploaded, they can have albums and so on. And they would like to share these files of photos with each other. In this case, when a user performs a share action, then there is a defined resource, which is in this case going to be a photo. And the principal is who would you like to share with. And in these cases, when there is a share request coming from the user, you can generate a policy for it, which in this case would look like the one in the right side here. You have the principal and the resource defined, but you can do this again and again every time that the user requests a share. And this is where templating comes very useful, because you can say that you have a template and you need to substitute the principal and the resource, and then you have the policy. But when you create the policy from a template, you need to substitute the missing values, and then afterwards, these policies are going to be linked to the template itself. And you can handle them as they are instantiated from the template. And when you make a change in the template, then these are going to be reflected within all the policies that are using this template. So if you think that this might be useful for you, then have a look at the tutorials and the documentation, which is at cedarpolicy.com, and see what you can use it for. And now, let's talk about Network Firewall. It's Macie going to be talking about Network Firewall.
Hello everyone, my name is Macie Küzdi. I am a cloud engineer here at Snapsoft, and I'm going to talk about AWS Network Firewall today. Before we jump right into the firewall, I have to say a few things about AWS networking, because the implementation of the network firewall would require a bit of knowledge about AWS networking. So anyone who didn't build an AWS network architecture, it would add a little bit of context about what we are going to talk about in the next few minutes. AWS services are hosted in multiple locations worldwide called the regions. Each region represents a geographical area in the globe, which are separated in different locations. They are all isolated from each other, so they don't have any connection between them. We have regions in Europe, for example, in like Frankfurt or in Ireland or in London, and maybe one day in Hungary, hopefully. Between those regions, we have the availability zones. They are also isolated from each other, and they add another isolation level to the services deployed to a region. We have the VPCs, which are short for Virtual Private Cloud. They are logically isolated virtual network. They act like network that we can use in a traditional data center, but with the benefits of using the scalable architecture of AWS. When you create a VPC, you have to assign an IP address range to the VPC where the services would operate. After we create a VPC, we can add the subnets into the VPC, which are a range of IP addresses, also a subset of the address ranges that you configure to your VPC. And each subnet must reside in a single availability zones. You can create as many subnets in your VPC as you want. And after you create a subnet, then you can deploy your AWS resources into your VPC. We have the route tables. Route tables are a set of rules which determine where the network traffic from your subnet or gateway is directed. And also we have the transit gateway, which are a network transit hub that connects the network components that we have taught previously. So you can connect two VPCs together with a transit gateway. Also, you can connect a VPC to an on-premise network with the help of a VPN, for example. Right, so after we talked about AWS networking, let's see what is a network firewall actually. It's a stateful managed network firewall, which is a managed service provided by Amazon Web Services that offers network security and threat protection to your AWS resources. You can also monitor and protect your network traffic with a wide range of predefined rules. And with the deployed network firewall, you can filter traffic for multiple use cases. For example, between two VPCs or to a NAT gateway or to a VPN if you want to traffic the outgoing or incoming traffic from an on-premise network. And also you can do the same if you are communicating with the internet from your services. And why you should use it? AWS Network Firewall increases the security over your network. It acts like the first line of defense against any unauthorized access. It controls incoming and outgoing traffic on a network level based on the rules that you defined. And it also enables you to enforce access control policies in your organization. It uses intrusion detection and prevention. It utilizes threat prevention for known threats or vulnerabilities, such as DDoS attacks or malware infections, or generally any unauthorized access can be prevented with network firewall if you configure it correctly. Also, network firewall utilizes deep packet inspection, which is a technology that examines contents of the data packet, but traditional packet inspection only inspects the header of the packet, while deep packet inspection could also filter for the payload of the data packet. So with the help of DPI, application protocols and patterns could be identified along with the network protocols. AWS Network Firewall also scales automatically with your network traffic, so you don't have to worry about manual scaling. And as I said before, you can monitor and log the network traffic within your AWS network. It can also seamlessly integrate with CloudWatch. And also, AWS Network Firewall has a cool new feature called the TLS inspection, which is deployed last month. So if you have a site, for example, that you are hosting on AWS with a certificate behind the load balancer, then you can attach the certification to your AWS Network Firewall, and then it can decrypt the traffic, filter for any unauthorized access, and then it will encrypt the network again for the other parts of the network. Let's see the components of the network firewall. We have the rule groups, which are a reusable collection of criteria for inspecting traffic and for handling packets and traffic flows that match the inspection criteria. For example, you can choose to drop or pass a packet or all packets in a traffic flow based on the inspection criteria. There are two types of rule groups. which is the first is the managed rule group, and then we can create custom rule groups also. Managed rule groups are managed by AWS, which offers prevention, for example, known botnet or any malicious activity. And then we can create our own custom rule groups, which we are going to talk about in the next slide. We have to create a firewall policy, which are a reusable set of stateless and stateful rule groups, along with some policy level behavior settings. Firewall policy basically wires the rule groups together with the firewall and with the default actions that you have to take with an ordering of priorities between the rule groups. Each firewall has to have one firewall policy, but you can use the policy in multiple firewalls. And then we have the firewall component, which does the magic. It connects the inspection rules that you defined in the rule groups with the firewall policy to the VPC that the rules will protect. And additionally, the firewall logs information about your network traffic. There are two types of custom rule groups. One is the stateless, which examines each packet in an isolation. So a stateless rule group doesn't consider context such as the traffic direction, or if it is a part of an existing approved connection. So stateless rule groups prioritize fast performance against more complex rules. And there are the stateful rule groups, which inspect packets in the context of their traffic flow. So they consider traffic direction also. So it's different than the stateless because it allows you to use more complex rules, but it might delay packets in order to group packets for inspection. And the stateful rule groups also enables you to log traffic and alert on matches. You can see a diagram here with the rule engine. First, the packet goes through the stateless rule engines, and if they doesn't match on any predefined rules, then the packets will go through the stateful rule engine, and it can drop or pass the packets along with the stateless engine. So there are three types of stateful rule groups. One is the 5-tuple, which is the most basic kind of stateful rules. There are 5 options that we can define for the 5-tuple rule group. One is the source IP address range, the source port, with the destination IP range, with the destination port, along with the IP protocol. We can define domain list rule groups. Domain list rules block HTTP or HTTPS traffic to domains identified as low reputation or that are known to be associated with malwares or botnets, for example. Or if you want to have a list of domains that we don't want to enable access from our services, then we can define them here. Also, there are Suricata compatible rules. Suricata is an open source network firewall which is used by AWS Network Firewall behind the scenes for the stateful rule groups. We can create rule sets defined with the syntax of Suricata. It's very flexible, highly customizable, so we can create more complex rules than we can do with the 5-tuple or domain list typed rules. And we can also filter for HTTP headers or body components with Suricata. How can we implement it? First, we have to create a firewall subnet dedicated to the firewall in each availability zone where we want to filter the traffic. Also, if you create a network firewall, then we have to keep this subnet dedicated for the firewall because it cannot protect any application that is running in the same subnet. And after we created the firewall subnet and we deployed the firewall there, then AWS deploys a firewall endpoint to those subnets, and then we can modify our route tables to route the traffic through this firewall endpoint. And we can deploy this subnet between many network components. For example, if we have a protected subnet that we want to filter the traffic to the internet with the outgoing or incoming internet traffic, then we deploy as it is on the slide. We have 3 deployment models that AWS recommends. First one is the distributed deployment model. In this deployment model, network firewall is deployed into each individual VPC that requires protection. So each VPC is protected individually, which enables us to manage those parts of the network independently, which reduces the possibility of misconfiguration, and it enables us to have VPCs that have its own network firewall rules. For example, we can use this deployment model to protect a workload subnet independently that has outgoing internet traffic between a VPC that only has internal network access. We have the centralized deployment model. In this model, a transit gateway is required, which acts as a network hub that simplifies the connectivity between the VPCs. And also we have to create a dedicated inspection VPC where we deploy our network firewall. In this deployment model, the inspection VPC has to have 2 subnets, one for the transit gateway and one for the network firewall. And then we can route the traffic that we want to protect through this VPC, through the transit gateway endpoint, through the network firewall. And then we have the combined model, which is the combination of the 2 previous models. So we can create a network architecture that utilizes both of these deployment models individually. And I have a demo for you guys, which utilizes the centralized deployment model. I will attempt to access the Jumpbox B deployed into the Spoke VPC B. As you can see on the diagram, I have a Jumpbox in the Spoke VPC A, where the traffic is routed through the transit gateway, through the inspection VPC and onto the Spoke VPC B. As you can see, I have the 2 VPCs here, and I can show you the firewall that was deployed into the inspection VPC. I have one rule group here that has one rule defined with the rule variables that contains the Spoke A and Spoke B IP address. So as you can see, I have only one rule which will not allow the traffic between those 2 VPCs because the first action defines a drop. So I have a script ready to go on the Spoke A Jumpbox, so let's connect it. Right, so as you can see, I have the test network firewall shell script, which does which tries to connect to the IP address of the second Jambox, and if it can connect, then it prints out an OK message, and if not, then it prints out the not OK, and it also does this periodically. Right. So let's see. Hopefully it will say not OK. Yeah, the Jambox cannot connect to the other Jambox, but we can fix this easily, as I can edit the rules that the firewall has, and I will just change the drop rule to a pass rule, and I can save it, and in a short few seconds, hopefully the network firewall will apply the new configuration, and we can see that the Jambox can now connect to another between the inspection VPC, between our network firewall. And that was the AWS Network Firewall. I hope you guys enjoyed it, and thank you for listening.